In this video, we are starting discussion 2, which is still on algebra and precalculus review. And specifically, in this video, we're going to review simplifying rational expressions. So I want to begin with a note that, remember that a rational expression has the form where we have a polynomial divided by some other polynomial. So polynomial divided by a polynomial. Alrighty, so let's look at a worksheet problem to practice this. So this is from our first worksheet, it's problem number 5. And I want to simplify this expression. So I want to begin by giving you 2 minutes to try this. 4, 3, 2, 1. Pause the video and try this for 2 minutes. Alrighty, let's go ahead and talk about it together. So even if you didn't quite finish, that's okay. Mostly I want you to be thinking about what the key ideas are. How would you get started? Alright, so to get this one started, let's factor out the common terms. So we are going to factor out some common terms. And we notice here that in the numerator, there are a couple of these 4x plus 1 to a power terms, here and here. So I'm going to be able to take out 4x plus 1 to the third because that's the smaller of those two powers. I also notice that there's an x minus 2 here. There's an x minus 2 squared there. So we're going to be able to take out an x minus 2. And the smaller power is a 1, so we're just going to take out x minus 2. And then if we look at the coefficients, this first term has a coefficient of 2. And the second term has this 4 and this 4, which will multiply to 16. So overall, I am going to be able to factor out a 2. All right, and when we do that, now let's write what's left over. So from the first term, what will be left over? So from all of this, what will be left over is we'll have a 4x plus 1. The 2 is completely factored out, and the x minus 2 is completely factored out. So that is it, 4x plus 1 there. And then from the next term, which is all of this, we had 4 times 4, which was 16, and we factored out a 2, which means we'll have a minus 8 left over. And then there will be an x minus 2, and that is it. So that is everything that's left over. And I put this all over the denominator, which is going to be 4x plus 1. And I have a power to a power, this raised to the 4th and then squared, so I multiply those powers to get 8. And now that the 4x plus 1 has been factored out of the numerator, I can cancel this with the 4x plus 1 to a power on the denominator. I'll cancel away 3 of those, and that'll make the exponent on the bottom of 5. Okay, so we end up with 2 times x minus 2. And the stuff in bracket we can simplify. So the stuff in bracket, we get 4x plus 1, and if I distribute the negative 8, minus 8x plus 16. And this is negative 4x plus 17. So we put that in the bracket, negative 4x plus 17. And then over our denominator, which was 4x plus 1 to the 5. And that is as far as we can take it. Alrighty, so that is our answer there. So let's do another practice problem. So this is question number 6 from the worksheet. And as a reminder, these worksheets are all posted on B courses. So it says, let f of x be x over x plus 2. And I want to simplify f of 2 plus h minus f of 2 all over h. So remember that we've seen expressions like this before in lecture. We did one example like this, sort of like this. And remember, this is called a difference quotient. It is called a difference quotient. Eventually, in our class, once we talk about limits, we will eventually take what's called a limit. Don't worry about that, what that is just yet, but we'll see this in chapter 2 of our textbook. we'll take a limit of this. And when we do that, it becomes what's called a derivative. And a derivative is one of the foundational topics from this class. It's going to be a really key, sorry, that was not a very good arrow. This is going to be a key idea in our class in Calc 1. All right, so I want to begin by having you try it. So pause the video for 3 minutes to try this question. 4, 3, 2, 1. Pause the video and try this question for 3 minutes. That may not be enough time to finish the problem entirely, but that's okay. I mostly want you to be thinking about what are the key ideas and how do I get started and make progress with this. Alrighty, so let's talk about it together, but hopefully you've tried it for 3 minutes. Okay, so on the numerator, I see f of some stuff in a couple of places. So let's start with f of 2. So to evaluate f of 2, whatever's in the parentheses, in this case it's a 2, I plug that into my function where the variable is, the x. So I'll plug in a 2 on the top for that x, plug in a 2 on the bottom for that x. Let me just highlight these. So this is my input, and it gets plugged in where those x's are. And then there's that extra plus 2 on the denominator. And simplifying this, we get 2 over 4, which is 1/2. We also have f of 2 plus h in the numerator. So I'm going to be plugging in 2 plus h as my input. So I write 2 plus h where the x is. So 1 on the numerator, 1 on the denominator. So here is, I plugged in 2 plus h, I plugged 1 in there as well. And then we have this other plus 2 on the denominator. And this I can simplify. I still have 2 plus h on the top, but on the bottom we'll get 4 plus h. All right, so let's put this together. Thus, if I write this whole fraction, f of 2 plus h minus f of 2, I'm just going to rewrite it all over h. F of 2 plus h, I know now is 2 plus h over 4 plus h, minus f of 2 we know is 1/2. And this whole thing over h. Alrighty, so now we need to simplify this. So on the top of this, I have a fraction minus a fraction. So let's get a common denominator. So 2 plus h over 4 plus h. I'll have to multiply this fraction top and bottom by something. And then we have minus 1/2. And I'll have to multiply that fraction top and bottom by something. All over the h. So the first fraction, I'll multiply top and bottom by 2. The second fraction I'll multiply by, on the top and the bottom, by 4 plus h. That'll give me a least common denominator. So now if I do that and I combine the fractions on top, if I distribute the 2 to the 2 plus h, we'll get 4 plus 2h. Then I get this minus, and then I'll have 1 times 4 plus h. But I should put that in a big parentheses, because it's got to be minus all of that. So 1 times 4 plus h is 4 plus h. So we have this. The denominator of that fraction is 2 times 4 plus h. I'm going to leave it factored like that, just because it'll be a little bit easier to see later if anything cancels. And then this whole thing needs to be over h. Alrighty, so let's continue to simplify. I can distribute this negative sign. That'll give me minus 4 minus h. And then if I combine terms on the top, the 4's cancel. Then I'll be left with 2h minus h, which is just h over 2 times 4 plus h. And then with this h on the bottom, let's rewrite that as a fraction. That's the same as h over 1. Because now when I divide by a fraction, so I still have h times, divided by 2 times 4 plus h. When I divide by this fraction h over 1, that's the same thing as multiplying by the reciprocal, 1 over h. So now this is nice. I can cancel the h's, and I end up with 1 over 2 times 4 plus h. And remember, as we saw in lecture, if there is sort of a denominator that cancels away completely like this, I need to remember what my domain restriction was. So from this h that I canceled away, that h is not allowed to be 0. Because if it was, that would have made the original denominator in the problem 0, and I don't want that. When I simplify, my domain needs to stay the same. So I need to write the fact that h is not equal to 0, because after it cancels away, that h, I can no longer see, just by looking at this fraction, that h is not allowed to be 0. That's why I need to write it in.